Hey, I hope you're ready to shake and bake today as we dive into simplifying roots or radicals that just happen to have some very nasty negative numbers underneath them. So by the time we're done with the video tonight, we're going to be able to solve all sorts of crazy expressions. And, like we'll see, okay, what's the square root of negative 20? You'll notice the common theme is we have a lot of negative numbers underneath all of these radicals. So to kind of help us set the stage, if you recall from our last video, we kind of introduced you to this imaginary unit. We kind of tried to establish the need for imaginary numbers and went over some of the basic powers. And we kind of organized the I to the 0, I to the first, I squared, and I cubed in our wheel, and we looked at the cyclic nature of those. But basically, we're going to really work hard on simplifying these radicals today. And so consider this. Consider the square root of negative 4. And certainly, Houston, we've got a major problem here because you'll notice, of course, if we take a positive 2 and multiply it by, let's see if we can get this set up. All right, if we take a positive 2 and multiply it by another positive 2, we're getting positive 4. Or if we take a negative 2 and multiply it by a negative 2, we're also getting a positive 4. So the question is, what number could I multiply by itself and get negative 4 as the answer? And quite frankly, it's just impossible. So our conclusion here is it is not possible to square any number, whether it be positive or negative, and arrive at a negative answer. Okay, it just cannot be done. In other words, the square root of a negative number does not exist within the set of real numbers. And again, that kind of drives the need for us to create this new number set, this new number system called imaginary numbers. And hence we were going to say we've got the imaginary unit to the rescue. So what we're going to do when you have something like the square root of negative 4, we're going to rewrite it as the product of negative 1 and positive 4. And then you can break that up. And what we could say is, we're going to end up calling this 2i. We'll kind of just flip-flop the order a little bit. But, of course, the square root of your 4 becomes the 2, and the square root of your negative 1 generates that I. Okay? Or let's say we have the square root of negative 9. Again, imaginary unit to the rescue. We can break that up and express it as the product of negative 1 times 9. And the square root of negative 1 multiplied by the square root of 9 is going to make 3i. So basically, as soon as you see a negative number, and let's say it's just negative 10, we're going to immediately call that I radical 10. If you see the square root of negative 15, we'll immediately call that I radical 15. So anytime you see that negative underneath the radical, we know that we're going to have an imaginary unit in our answer. So now I think what we could do here before we move on is I want to go out on a little brief tangent right here and talk about cubed roots as opposed to square roots. So believe it or not, cubed roots can handle those negative numbers underneath the radical. And there's actually the answer here is a real answer, just negative 2. And the reason for that is if you take negative 2 and you repeat it 3 times, you actually get a negative 8 as the answer. So in that case, you will have a real answer. It's just like when you have square roots or fourth roots or sixth roots down the road, anytime the root is an even root is when you could run into those imaginary numbers. Okay, so let's see if we could simplify the square root of negative 16. And one trick that I like to do is, we could go negative 1 and 16 and immediately call it, I radical 16 if you want, and that turns into 4i. But I'll tend to, probably moving forward, you're going to see me just skip this step right here and go right to the I, okay? As soon as I see that negative number inside, I'm going to go right to the I. So on this next one, where we're trying to simplify the square root of negative 20, we'll go right to the I radical 20. And then we could simplify 20 into 4 times 5, and you'll end up with 2I radical 5 when you're all done. Or negative 63. Let's just go right to I radical 63 to start with. And then we can break down the 63 into 9 and 7. And we'll end up with 3I radical 7 when we're all done. Okay. So ultimately, I want to kind of combine and add like terms here, but what we want to do is we want to simplify these radicals first, okay? So if you want to make a little note to yourself, just say simplify the radicals first. I'll go ahead and highlight them. So we're going to simplify that square root of negative 100 and the square root of negative 36. So we'll have 4 minus 10i plus the quantity 7 plus 6i. And then if I combine like terms, I'm going to combine the 4 and the 7 to make a nice 11. And then we can combine the negative 10i and the positive 6i to make negative 4i. And right there is my final answer. That's as far as we could go. We can't combine the 11 with the 4 because they're not considered like terms. It's really, really, really similar to like if you had 11 minus 4x and you said, okay, I know I can't go further there. Same reasoning. We just don't have like terms. Okay. So what I'll do first on this next one is, we could say 9 plus I radical 12 minus 4 minus I radical 75. And then we could work on simplifying them a little bit further. Let's see, that radical 12 could be 4 and 3. And let's see, that 75 could be 25 and 3. And as I simplify those radicals, I'm going to get 2i radical 3 minus 4 minus 5i radical 3. So, and again, with some more practice, I think you're going to be able to skip some of those steps maybe in there. But when you're first learning how to simplify these radicals, I think it's beneficial to just kind of take your time and show as much work as you can. Now, what I've got to do is I'm going to take this minus sign and I got to distribute it. So we've got 9 plus 2i radical 3 minus 4 plus, see that plus sign in there, 5i radical 3. We'll combine like terms. So if we combine the 9 and the negative 4, we'll get 5. And then we'll combine the 2i radical 3 with the 5i radical 3 to get 7i radical 3. And that, ladies and gentlemen, is our final answer. Okay. So again, I think these last two problems here, again, if you're going to make a note to yourself here, just continue to reinforce the idea that we're going to simplify that square root first. And over here, we're going to simplify the square root first. So all of our energy goes into simplifying that radical. So we've got 8 plus I radical 32. Now, the bad news is 32 is not a perfect square. But the good news is 32 is divisible by a perfect square named 16. So let's say we've got 8 plus, this radical 16 is going to make 4i radical 2 over 4. And when you organize this in your mind here, you've got 1, 2, 3 terms. And you have to confirm that all 3 terms are divisible by the same number. In this case, they're all divisible by 4. So we can go ahead and reduce. And that's going to make 2 plus 1i radical 2 all over 1. And that is going to be our final answer. Okay, moving on to our last one here. I'm just going to rewrite this as I radical 200. Again, the bad news is 200 is not a perfect square, but it is divisible by a perfect square. In this case, it's divisible by 100. So we'll go radical 100 and radical 2. So we could rewrite this as 15 minus 10i radical 2. And again, let's see, what are all 3 of these terms divisible by? Let's see, this guy and this term and this term, they are all divisible by 5. So we're going to get 3 minus 2i radical 2 all over 5. And that's our best, most simplified answer. So hopefully we feel pretty good about why there's an I in our answer and how we're going to handle these negative numbers underneath the radical sign. And we'll see if we can tackle some big bears tomorrow in class. Take it easy.